Day 544 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3,370, smallest number with all set bits. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a positive integer n. Return the smallest number x greater than or equal to n such that the binary representation of x contains only set bits. All right, y'all, so that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get into the examples, let's look at what the definition of set bits is. It says a set bit refers to a bit in the binary representation of a number that has a value of 1. So when it says only set bits, that means its binary representation has only ones, excluding the leading zeros. There may be some leading zeros, but we're not worried about those. We're only worried about the ones, and without the leading zeros, it should be all ones. So let's take a look at example 1 to see what I mean by that. So in example 1, we have the input n equals 5, the output is 7. Explanation says the binary representation of 7 is 1, 1, 1. So let's break this down one step further just to make sure we know what's going on, right? So in binary, 5 in binary would be equal to 101, right? 6 in binary would be equal to 110. And 7 in binary would be equal to 111. So we want the smallest number x that is greater than or equal to n. So in this case, n is 5, but n is not all set bits, right? It's a 0 right here, so that doesn't count. 6, then after 5, we have 6. 6 is not all set bits either because it's a 0 right here. Now, if the 0 would have been leading, that'd be different, but that'd also be a different number. So 6 right here is 110. Since there's a 0, it's not all set bits. 7 is 111, right? So 7 is all set bits, and it's the smallest number that is after 5 that we get to first that has all ones or only set bits of 1. So, or only set bits, that's why the output is 7, because 5 doesn't, we want something that's greater than or equal to n. So in this case, n is equal to 5. 5 is not only set bits, so we keep looking. 6 is not only set bits, so we keep looking. 7 is only set bits, so we can return 7 because it is the smallest number that is greater than x, or the smallest number x that is greater than or equal to n. So 7 is the smallest number that is greater than or that is greater than 5 that has all set bits. So that's why we return 7. So just in case that didn't make sense, let's take a look at example 2. So let me get rid of this. Boom. So in example 2, n equals 10. The output is 15. It says the binary representation of 15 is 1, 1, 1, 1. So let's go through all of these binary representations again. So 10 in binary would be equal to 1010. That's not all ones. So let's see what 11 is. 11 in binary would be equal to 1011. Once again, that's not all ones, so we have to keep going. 12 in binary is equal to 1100. Once again, not all ones, keep going. 13 in binary is equal to 1101. Still not all ones, still keep going. 14 in binary is equal to 1110. We're getting close, but still not all ones. But 15 in binary is equal to 1111. This is all set bits, which is what we're looking for. It's the smallest number after 10 that we can find that where we reach all set bits is 15, right? So that's why we return 15. So just in case that didn't make sense, let's take a look at example 3. Example 3 is a case where n is equal to the smallest number with set bits, right? So in example 3, n is equal to 3. The output is 3 because the binary representation of 3 is 11. So This input in already has all set bits, which is 1 1. Sorry, I shouldn't say 11, but it's 1 1. So we could just return 3 because it's already all set bits. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. Now, the first thing we need to do is we're going to initialize a variable num, and we're going to set it equal to 0. And this will store our progressively built number. So we're just going to come right here in the function, declare a variable called num, and set that equal to 0. Boom. Now we need to continue looping until num is greater than or equal to n. So we're going to say while num is less than n, we're going to open up the brackets, and we're going to left shift num by 1, and this is going to, then we're going to add 1 to it, and this is going to effectively append a binary 1 bit at the end of the current number. So for example, 0 would be 1, and then 1, we would add another 1, so 1 would turn into 3, then add another 1, 3 would turn into 7. And when I say that, I mean first we start from 0, right? And then 0, well, let me show you the code first, and then I'll show you what it does. So the code will go num equals num left shift 1 plus 1. So what this is effectively doing is, say we have 0, then that 0 would turn into 1, right? And this is binary. So then that 1 would turn into 3, which is 1 1 in binary. So just imagine we adding a 1 to this one. So let me just put it like this. This could be the actual number, and then this will be the binary. Boom, we'll put a 1. So then 1 turns, we 0, boom, we left shift, we add the 1, left shift again, and add the 1. So now 3 would be 11 in binary. Boom, then once again, let's left shift again. That's going to take us to 7. Or let me put that 7 in parentheses, which would be 1 1 1. Then once again, keep going. That next would be 15, which would be 15, which would be 1 1 1 1. So as you can see, it's just adding a 1. We had 1. First we had 0, then we had 1 1, then we had 2 1s, then we had 3 1s, then we had 4 1s, so on, so on. Boom. So that's what this line is doing right here. Boom. Then once num is longer, excuse me, this is only going to run while, sorry y'all, that should be while num is less than n. This is only going to run while num is less than n. Boom. Then once num is no longer smaller than n, we can return it, and the result will be the smallest number with all set bits. So we could just say return num. Boom, y'all. That's all the code. It's that simple. Let's give it a run before we submit it. Make sure it runs properly. It's accepted. So let's go ahead and submit it. Make sure it's still accepted. Let's see. It's going a little slow, but there it is, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.